In this video, we're going to look at more applications of quadratics. Quadratics. In this problem, we're going to look at a box problem. And here's what I mean by a box problem. This is a piece of machinery cuts rectangular sheets of metal such that the length is 3 times the width. Equal-sized squares measuring 5 inches on a side can be cut from the corners so the resulting piece of metal can be shaped into an open box by folding up the flaps. Let's pause there and let's kind of examine what this looks like. So this tells us that we have a box, or a rectangular sheet of metal, in which the length is 3 times the width. So I could start off by just labeling it this way. If this width has a length of x, then the length would be 3 times that. And that's kind of this first sentence. But then it says, I'm going to do this part in blue, it says equal-sized squares measuring 5 inches on a side can be cut from the corners so that the resulting piece of metal can be shaped into an open box by folding up the flaps. Now, what it means by that is it means if I were to cut out a little square from this corner that's 5 by 5, and I were to do the same thing in all the corners, and we were to cut out these little sections, these little 5 by 5 sections, what you would have is you would have basically a net for an open top box. And so if I were to take that and fold it up, I'm going to kind of draw it over here to the side, you would have this length right here, but then this part would get folded up in front. We're going to kind of do like a 3D view here. And actually, I'll do that in blue so you can see that that kind of folds up like that. And it's going to kind of look like this, okay? So here's our box now. We took it and folded it up. So maybe if I were, I kind of want you to make sure and see how these dimensions connect to these dimensions over here. So make sure you see that this part right here that I'm shading, that becomes the bottom of the box once we fold everything up, okay? Maybe think of this as like face 1, that would be there. This would be face 2, that would be there. Face 3 would be there, and face 4 would fold up to be over on the side, okay? I'm going to make those go away. I really want you to see that connection. Now, what we have to think about is while the original sheet of metal had dimensions of 3x by x, you got to think, this box, this length right here is not the same 3x here, because 3x went all the way from this point to this point, but we cut off 5 inches there, and we cut off 5 inches there. So this distance on the base of our box is not going to be 3x, but it's going to be 3x minus 10. I got the minus 10 because it's 3x minus 5 for this part and 3x minus 5 for this part. Okay? And then this distance on the box is not going to be x because once again we cut off 5 inches there and we cut off 5 inches there. So if maybe this length right here was a full x number of inches, this right here is what we're looking for, and that's going to be x minus 5, which is x minus 10. And then once we fold the box up, the height of the box is going to be this length right here. See how, hopefully you can visualize, if I cut this little shaded square out, that this line and this line would fold up, and they would meet right here. So this length, or excuse me, this height is going to be 5. For this box that we made. So we've got our open top box, which has a length of 3x minus 10, a width of x minus 10, and a height of 5. Now we're ready to tackle the rest of this problem. It says, if the volume of the box needs to be 435 cubic inches, determine the dimensions of the original piece of metal. So what we're going to do is we're just going to set up an equation and solve using this, and once we solve for x, we'll be able to figure out what the original dimensions were. So to find volume, that's length times width times height. So in this case, they tell you that the volume is 435. Our length, we'll use 3x minus 10 as the length for our box. We'll use x minus 10 as the width of our box. And then our height is this 5 right here. So now we've set up our equation. I just want to solve this quadratic equation. What I'm going to do first is I can see that this number is divisible by 5 and this side's divisible by 5. So why don't I just divide each side of my equation by 5 to kind of simplify our quadratic a little bit. That will give us 87 equals 3x minus 10 times x minus 10. And let's kind of relocate our math over here and continue. So if I have 87 equals 3x minus 10 times x minus 10, we're going to distribute 3x squared minus 30x minus 10x plus 100 equals 87. Then, with actually, we can combine some like terms. I have 3x squared. These two terms right here can combine to become negative 40x. And then I'm actually going to subtract 87 from each side to make our quadratic equal to 0. And 100 minus 87 is going to be 13, and our quadratic's equal to 0. From here, I'm a little bit worried about running out of space in this problem. We can do quadratic formula. That's probably what I would do. So we have our a value is 3, our b value is negative 40, and our c value is 13. So we have x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now, for the sake of space, I'm going to skip the actual solving of that. I'm going to skip a few steps in the simplifying of that. And what you're going to end up with is you end up with two solutions. X equals 2 over 6 and x equals 78 over 6. Now that 78 over 6 will actually simplify to a 13. So you got one solution and you have another solution. These are both, oh, and I guess I could simplify that first one. These are both valid solutions to this equation, or to this equation, I should say. If I were to substitute 1/3 in for the x's, the right side would equal the left side. That would be true. However, we have to think about the context of the problem. If this entire length right here is x, and we said that's 1/3 of an inch, we would not be able to cut away 5 inches on one side of that and 5 inches on another side of that. Therefore, our domain in this problem excludes that solution. That would be an extraneous solution because that can't have a length of 1/3. There'd be no way to cut 5 inches off of either side. It's too small. And so what we do is we come here. So if x is 13, okay, if x was 13, that would mean that 3x would be 39. Those would be the dimensions of our original box. It would be 13 inches this way, 39 inches this way. And I think I misspoke. I said the dimensions of the box. That would be the dimensions of the sheet. It would be a little bit less than that for the dimensions of the box.